For those who are not in class today, you need to know that I handed out a lovely orange textbook, and we also talked in quite a bit more detail about the class expectations and procedures for this year. So when you return, make sure that you take care of those items. You'll actually want to notice that if you open your book up to, I believe it's the front cover, the next page in front cover, you'll be able to check your answers from last night. I asked you to fill in the radians on the bottom half of the circle. You should have been able to, or you'll be able to check those in the book, or you can check them right here. How do those angles look? How do those numbers match up? Do you have any questions? Our next step is to our next step in continuing to understand radians is for me to give you a new radian and see if you can figure out where that would be located. So what if I gave you 4 pi over 7 radians? Where is that going to show up? Now, if you were in class, I would be purposely giving students time to just try to figure this out. If you're watching the video, then you need to pause it so that you can figure this out. If you're just going to keep watching, you're going to miss out on the thinking. You're going to miss out on the opportunity to try something. Now, students will say, but I don't know how to do this. Well, I'm wondering if you can take some of the learning from yesterday, maybe apply some new thinking, and figure out where is 4 pi over 7. Now, if the only thing that's hanging you up is simply remembering the quadrants, then let me remind you that this is quadrant 1, 2, 3, and 4. So it's time to pause the video, see if you can maybe make a good guess, or better yet, come up with a method to determine the location of 4 pi over 7. Now, maybe one of the more common methods for students is to, in some way, do some comparing. I'll say generically that we're going to compare some numbers. There's different ways to do this. Sometimes a student will say that it's kind of like you have 4/7 of pi. And 4/7 of pi is a little more than half of pi. And a little bit more than half of pi should rotate you around to quadrant 2. And there will be a number of students who they just kind of look at the fraction and do a little bit of comparing. There's nothing wrong with that method. To give it a little bit more solidness to it, I'm going to suggest that we not just compare the fraction, but we actually determine the entire decimal. What I'm referring to there would be to type in 4 pi over 7, literally to divide those numbers. And when you divide 4 pi over 7, you get 1.79, give or take. Now, 1.79 represents 1.7 of these, 1.7 radians. But exactly how big is that? Well, if you remember with me that at the top up here, we have 1.57. Now that's equivalent to pi over 2. Over here on the left, we would have 3.14. Of course, that's equivalent to pi. And I think everybody knows that 1.79 is somewhere between those two values. And so this is essentially a way of comparing the actual value of 4 pi over 7. Now, another method would be to convert. And again, if you had been in class, once in a while a student will say that they actually found the equivalent degree measurement for 4 pi over 7. This is certainly a little bit more mathematical, but it turns out that it's no more difficult. In fact, it's actually a little bit easier. It's just simply realizing that we can create and use a ratio. Now, the ratio is always going to be pi to 180 because, well, they are equivalent. And you'll notice that I have radians in the numerator, but degrees in the denominator. Of course, ratios like to be turned into proportions. That is, when we have it set equal to a second ratio. And the cool thing here is that I can fill in 4 pi over 7 in the numerator and then leave that unknown degree for the denominator. Oh, so I can solve a proportion. Now, when you solve this proportion, yes, you should use some simple algebra, cross multiply. I'm certainly going to show it. There is something, though, to notice that happens when you cross multiply, and that is that pi is on both sides. And since pi is on both sides, algebra would say that I can cancel those out or divide them away. And it looks like I end up with a simple calculation, 180 times 4 sevenths. In other words, 4 sevenths of 180. And we end up with a degree value, 102 some degrees. Again, a couple decimals is fine, but basically we get 102 degrees. And I'm going to assert that you should know where 102 degrees would be. 102 degrees is certainly past 90 degrees, and again, in quadrant 2. So 4 pi over 7 is actually an angle. It's big enough to rotate us around to quadrant 2. And whether I compare numbers or actually convert it, I can make that conclusion. Before I give you another one to try, here's just like a little carve out. I would still put it in your notes. I just haven't talked about this yet, and now's the time that I want to. When you rotate on the x and y axis in this direction, did you see the direction that I turned? That's a positive rotation. And honestly, that's the way that all of our rotations have been up to this point. But you can probably guess that since I mentioned that that's a positive rotation, that we have the opportunity to do what's known as a negative rotation. I want you to watch the direction I'm going, and that's also can be denoted with a little rotation arrow. But when we go in that direction, that's known as a negative rotation. Now, a couple things we want to realize here. Negative doesn't mean that I'm in a negative place. It doesn't even make sense, actually. It's more just the direction that I'm going. And secondly, when I have a negative rotation, all of my common angles, well, they become negative. So this would be negative 90. Make sure you read that correctly. That's negative 90. This would be negative 180. And now this would be negative 270. And of course, if I come all the way back around, I'm at negative 360. Sometimes students say it's just the same numbers, but we want to be careful and technical to say that it's actually not the same numbers. They actually are the opposites, and they're in a different position. Negative rotation. Why would I show you that? Well, so that you can try this. Now, same thing. If we were in class, this would be a pause point. You should be trying to figure this out on your own. I would imagine that you're going to take something that you saw in the last example. But where is negative 13 pi over 8 radians? If the only thing that's kind of keeping you from trying to finish this, I want to hopefully affirm to you that the quadrants remain the same. The quadrants are always 1, 2, 3, 4 in this way. It doesn't matter if there's a negative angle. Of course, the mere fact that it's a negative angle is probably going to affect the direction that you rotate. Pause the video, figure this out. All right, how did you do? If we compare the numbers, we want to be ready to be thinking about the negativeness of this angle. That is, I want to be ready to compare it to negative 157. That's just negative pi over 2, negative 314, negative 471. That's, of course, negative 3 pi over 2, and then maybe negative 6.28. Sometimes students will say, should I memorize these 4 numbers? Well, you should know how to find them, and they do come from those common rotations that I mentioned that use pi. So about negative 13 pi over 8. Well, if you divide that on a calculator, you get negative 5.11. You get about negative 5.11. Now remember, this is a negative rotation, so I have to rotate in a negative way. That means I'm going to go this way, past negative 1.5, past negative 314, hey, past negative 4.71, but not all the way over to negative 6, because I only wanted to rotate negative 5.11. It looks like, though, that ends up causing me to rotate, well, back into quadrant 1. Quadrant 1 ends up being your correct answer. So that's the comparison method. And how about the converting method? The truth is, you should be comfortable with both of these because, well, there's always the ratio pi's to 180. And in this case, I'll end up with negative 13 pi over 8 equaling that ratio over some unknown x. Students will say, is it always going to work this way? Well, what do you mean always? Are we always going to have this ratio? Yes. Can we cross multiply? For sure. Are the pi's always going to cancel out? Listen carefully. They will, as long as they're on both sides of the equation. Now, if you're asking me if they're always going to be on both sides of the equation, the answer is, I don't know. Why don't you see as you work through some different examples? But if pi is on both sides, yeah, it's going to cancel. And you basically are doing 13/8 of 180. And 13/8, negative 13/8 times 180 is negative 292 and a half. Now you should know that negative 292 and a half is going to get us to rotate all the way back around to quadrant 1. Okay, just so you can see me draw it, negative 292 is, of course, in the same place. It's past negative 270, but not all the way to negative 360. Okay, so these, so to speak, new radian values still represent angles, which brings us to the last one, 5 radians. Now, this is a little bit of a special question. A couple comments. First of all, it's not missing the pi, or meaning that you don't assume that the pi is there. In other words, this would be different than 5 pi radians. Okay, it's not 5 pi radians, it's just 5 radians. What do you mean? What do you mean 5 radians? You mean like 5 of these? Well, yes, I do mean 5 of those. I mean, like I could just take 5 57s? Well, if you understand that 57.3 degrees is 1 radian, and you multiply it by 5, then you would be in the ballpark of understanding exactly how big this angle is. How about our kind of like our little converting method? You know, that's kind of what I've done already here. I guess we started to do a convert, but how about if I use that converting method, if I use that ratio method to do my converting? Well, if you do that, you want to make sure that you only put 5 in the numerator, not 5 pi. And when you cross multiply, you'll see that you're going to multiply 5 times 180. Just kind of double check that. Okay, 900. But the pi doesn't cancel out. Looks like I have to divide it. Now, 900 divided by pi is a little bit more of a mathematical way for us to end up with 286, technically 0.48. How about if I just compare the numbers? If I just do some comparing. Keep in mind that up here is about 1.5 radians. Over here is about 3 radians. And down here is 4.7. Of course, back to here is about 6. But I guess we don't really have to overthink this because 5 radians is going to be somewhere between 4.7 and 6. So either way you look at it, 286 degrees or just 5 radians is going to get you down here to quadrant 4. All right. Now for homework tonight, there's a sampling of questions that'll continue to get you to work with radians. You'll use maybe a combination of methods that you've seen here. And I even know that there's a few questions mixed in that assignment or mixed in that homework that is going to cause you to extend even beyond what we've done. So check that out. Should be on my webpage, and you'll need a book, of course, to work through those questions.